This is a video for MEI Core Pure, Calculus 2 Inverse Trig Functions 2.4, integrating using arctan x. We already know that if we differentiate arctan x, we get 1 over 1 plus x squared, with a more general result being the derivative of arctan x over a is a over a squared plus x squared. So how does this help if we're integrating? Well, if I look at this first expression, if I integrate the right-hand side, so 1 over 1 plus x squared dx, I should get arctan x. Plus a constant of integration, I've got an indefinite integral. So how about this one? Well, instead of integrating the whole of the right-hand side, I'm going to integrate just 1 over a squared plus x squared. That means that this is 1 over a times the size of the thing I've got on the right over here. So I'm going to get 1 over a times the inverse tan, that's arctan, x over a plus my constant. There, that is tidied up so you can read it a bit more easily. And this second one here is going to be by far the most useful when we come to look at integration. So how can we do this integral? Well, we can do a comparison, so we can compare this with the standard form, that being the integral of 1 over a squared plus x squared dx. And we can see that this thing and this thing are very similar, and in fact, if I use a equals 4, this is the same as this. So I can just quote the result. The result of this integral is 1 over a, so in this case that's 1 over 4. Inverse tangent, so arc tan x over a, so x over 4, plus my constant of integration. And again, typed up so you can read it easily. So how about this one? Well, a problem here, I've got 3x squared instead of just x squared. So I'm going to do a bit of factorizing first of all, take that 3 outside the integral to see what's going on. So if I take out that 3, it becomes a 1 over 3 outside the integral. I'm going to get 1 over. Now I've taken a 3 out, so I get 16 over 3 from the first bit, plus x squared from the second bit, dx. And now if I do a comparison with the standard form, the integral of 1 over a squared plus x squared, I can see that if I use a value of 4 over root 3, that gives me that integral. So I can write down the result. I need the 1/3 copying through from here, and then I need 1 over a, which is root 3 over 4, times arctan x over a, so that's x root 3 over 4, and that's plus a constant. So we could tidy this up a little bit more. We can write that as 1 over 4 root 3 arctan x root 3 over 4 plus a constant. Again, that's tidied up a bit. You'll see here is where we've taken out the 3, and then it all gets copied through with the tidying up at the end. So in summary, you can always quote this standard result. 1 over a squared plus x squared integrated gives me 1 over a arctan x over a. And don't forget the plus c if you've got an indefinite integral. If the coefficient of the x squared is not 1, then factor that out of the denominator so that you've got it in standard form. That was the final video in this section, Calculus 2, Inverse Trig Functions.